So I'm going to tell you about how we measure dark matter, since it's invisible. What I have here is a cartoon of how we measure dark matter. In cosmology, we measure distances with a unit called z. So we're here at z of 0. We're the observer. We're 0 distance from ourselves. And here's our telescope. And we look at distant galaxies out in the universe. These distant galaxies that are of z about 1. And that might sound like a small distance, but how we do it in cosmology is a distance of 1 is actually about halfway to the edge of the visible universe. So this is a very distant galaxy. In the absence of anything between us and that galaxy,
And God said,
Let there be a firmament in the midst of the waters, and let it divide the waters from the waters.
and God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. And it was so. And God called the firmament heaven, and the evening and the morning were the second day.
the light from this galaxy would take a straight path to us. But we know from the work that Vera Rubin and others did that there's all this dark matter out there in the universe. And we're particularly sensitive with this technique to dark matter that's about halfway between us and the distant galaxy. Excuse me. One of the consequences of Einstein's theory of relativity, our theory of gravity, is that mass bends space. So what this means is the light, when it gets near this dark matter, won't take a straight path to us. That light is going to take a distorted and curved path. And I'm showing a very, very exaggerated version of that here, so it's easier to see. The consequence of this is that we will not see the galaxy as it actually is. We'll see a distorted version of the galaxy. So the dark matter between us, which we can't see, has distorted our image of this distant galaxy. And in doing so, it's telling us something about the dark matter. So I'm going to tell you with one more analogy. I'm going to use another analogy for how we measure dark matter. This is a penny in a pool. That's the analogy here. And full disclosure, Alina and I don't actually have a pool. So you're looking at a penny in our bathtub, but penny in the pool sounds better. So in this analogy, the penny is like the distant galaxy. And the water in our bathtub, or the water in a pool, is like the dark matter. You don't see the water here, but you know it's there because you see the effect on the image of the penny. So what's happening is the light is coming to us from the penny, and it's taking some distorted path that changes our perceived shape of the penny, so that we know the water is there. So that we know the water is there. In much the same way as the light from a distant galaxy comes to us, takes a distorted path through the dark matter, and we see a distorted image of that galaxy. But we don't see the dark matter. We don't see the water. So that we know the water is there. I could tell the density of the water and how much water there was, and that's going to tell us a lot about the properties of dark matter. That's how we're learning about dark matter now, and that's how we're going to learn about dark matter in the future.
He made darkness his secret place. His pavilion round about him were dark waters and thick clouds of the skies.